All right, this is what are we, Math 54? And we are doing the book we're using, it starts with 5.2. This is on trigonometric functions. This has sine, cosine, and tangent. That's this section. Okay, if you know SOHCAHTOA, we're gonna do that in 5.3. Because there's something that sine, cosine, and tangent are more importantly for than just SOHCAHTOA. SOHCAHTOA is strictly for triangles. Sine, cosine, and tangent are related to the angles themselves and not triangles. So if there's not a triangle, it's still applicable. So we're gonna say we have, I draw a little axis here. And we have some ray here where this point ends in the point XY. And the angle that it sweeps out from the x-axis is theta. I'm gonna make a triangle to illustrate why it's the following stuff is gonna work. But this stuff holds true even without the triangle. This value here is x, which means this length here is x. This distance here. This position here is y. So that distance is y. And we're gonna call this side here r. The reason why we call it r is because this could go all the way around the circle, it could sweep out anywhere, starting from the center and go in any direction. So r is for radius, it actually makes a circle. As we sweep out, as theta goes from 0 to 360. R sweeps out the radius of a circle. So we call it R. Now, hopefully you remember from algebra or previous classes, if it wasn't called algebra at your high school, Pythagorean's formula, a squared plus b squared equals c squared. If we apply that to this triangle here, we have x squared plus y squared equals r squared, which is the equation of a circle. And if I take the square root of both sides, I get r equals the square root of x squared plus y squared. The reason why I'm pointing all that out is because we need some of this stuff for what we're about to do. We have 6 trigonometric functions. So Sine. Of theta. Pronounced sine. Equals y over r. Cosine of theta, which we give it COS, which is fun because that's the abbreviations of our school. Cosine theta equals x over r. And tangent theta, which we go by TAN, is y over x. And that's tangent. That's probably the form you're the least familiar with if you know SOHCAHTOA. Most people that have done triangle a little bit before know SOHCAHTOA, but don't remember this. But this is actually the more important one. Then we have the three that are related to it. This one here, sine is paired up with it's CSC theta. This is pronounced cosecant. It is r over y, which is the same thing as 1 over sine theta. Then we have SEC theta. This is pronounced secant. And this is r over x, which is 1 over cosine theta. And finally, we have cotangent, which looks like cot. Cotangent. And that is x over y, or 1 over tangent theta. So these three right here, connecting this and this, these are called the reciprocal identities. I don't know if that name's important. I don't feel it is, but in case you want more math jargon, I never know if there's gonna be like a math person in the room that likes math more than me. They exist. I'm an applied math teacher, so like I like applications of it, using it as a tool. That's what it was created for. There's a lot of people that like math that are pure. Doing it just for the challenge of it. Something else to keep in mind, I didn't state it specifically here, but. None of the denominators can equal 0. So if like x equals 0, tangent theta is not gonna equal a real number. It's gonna have to equal infinity. Which is not a number. So these are the 6 that in all reality, the 3 important ones are the 3 on the left. Because you can always flip them over to get the other 3. Right? This is just that one flipped over. This one is just that one flipped over. And that one is just that one flipped over. How do you remember which ones pair up? This is the way I do it. This one starts, well, this is the way I did it when I was learning. The S pairs up with the C on this one, and the C pairs up with the S on this one. They go to the opposite ones. The opposite letter. Other letter. Some people want to pair sine with secant because they both start with S. Some people want to pair cosine with cosecant because they both start with C. And that's just not how it works. It's the other way around. I don't know why. I don't know who named this stuff. Anyone need this? A couple of you are still writing. Patience. It's important that this point has to start here. It has to start at 0, 0. That has to be 0, 0. Because otherwise those lengths are not correct. Make that clear. Cheated, that's a perfect circle. Alright. So let's look at an example. Let's say we have a ray. That starts at the origin. And ends at 12, 5. Find the 6 trigonometric values. All right, so let's draw a little picture. Pictures always help. Well, not always, but usually. Five, 10, 15, 5, like 12, 5 might be like right there. So that's 12 and this is 5. So if it helps to blow up that triangle a little bit. This side here is 12 and this side here is 5. And this is why we say it has to start at 0, 0. If I had started it like right here, the bottom wouldn't be 12 long. For us to use the values, like this value has to associate with the position. So this is R and we don't know what that is, but we can find it. R was equal to the square root of x squared plus y squared. So R equals 12 squared plus 5 squared. And that's 144 plus 25. Square root of 169. R equals 13. So x equals 12, y equals 5, r equals 13. We're going to go through and fill out our 6 trig functions. Write them down real quick. You can write down the relationships again real quick. In fact, you probably should until you have them memorized. Now, I'll be honest, I only have the 3 on the left memorized. I remember y over r, x over r, and y over x, because I know how to flip things. So I don't need to memorize r over y or r over x, I can just, I'll go to the other one and flip it. But if you like memorizing everything, enjoy. So we'll plug in what we got. Y here, sine theta is y over r, y is 5 and r is 13. Which means cosecant is that upside down. Cosine is 12 over 13, x over r, which means secant is 13 over 12. And tangent theta, y over x, y is 5, x is 12, so this is 12 over 5. All right, you guys try. Ray ends at, let's go with -8, comma 6. Give you a couple minutes to do this. you'll see when you try to draw this. Like -8's over here and. Oh shit, let me put it down here. -8, and I'll call that 6 right there. We'll go with this as 0. I fucked all that up. You know what? I did fuck it up. Rather than try to salvage that graph, we'll just do a new graph. So -8 and 6. Like this is the angle theta here. And this is why I say it doesn't actually correspond necessarily to the triangles. SOHCAHTOA is specifically for triangles. Here we can still use this triangle to do it, but notice that this angle is not that angle right there. We'll talk about their relationship later on, another day. But it still works here. The y value is 6. The x value is -8. So we can still calculate r. R is the square root of -8 squared plus 6 squared, which is 64 and 36. Square root of 100 is 10. So if I write down my values, I've got x equals -8, y equals 6, and r equals 10. And we can start doing our values here. Oops. All right, sine theta is y over r. Y over r equals 6 over 10. But that's not reduced, is it? Those are both even numbers. We want to write things in the simplest form. We'll say thetas. Cosine theta is x over r, -8 over 10. We can reduce that to -4/5. And y over x, y is 6. X is -8. This will reduce to -3/4. Y over x. And for these, we just flip them. So 5/3, -5/4, -4/3. It actually reveals something kind of neat. Like the triangle I have there, that has a length of 8 on this side, a length of 6 on this side, and 10 on that side. But all these numbers have 3, 4, and 5. When I simplify it. And in both cases, this theta is the same. So these are called similar triangles. And they're proportional. One is just scaled up version of the other. And for similar triangles, the 6 trig functions are equal. You would need a little bit longer. A couple people still writing. We're actually going to take advantage of this property in the next problem. So like we're gonna have let's use the line. Three x minus 2y equals 0. And we're gonna have x is less than or equal to 0. And find the 6 trig functions associated with the angle. Now this isn't gonna be intuitive. Hopefully, maybe it is for you. If I solve this for y, let's see, I get negative 2y equals negative 3x. And I divide by negative 2 and I get y equals 3/2 x. And if I put in plus 0, I can see the y-intercept is 0. And if I do rise over run, it's doing 3/2. Alright, so like theta, it says x is negative, so we're looking at this part of the line. X is less than 0 over here. We're looking at that part of the line, which means this is doing that. That's our theta.
So Professor Jones, we can use any point from the third quadrant.
We can use any point from the third quadrant, that's correct. We were saying that I was just about to go with that. So I'm gonna show it on the first quadrant, but it's gonna apply on the third quadrant. Like we were saying, the similar triangles, any triangle I make here. If I do a little triangle or I do a big triangle, like that's a little triangle. That's a bigger triangle. And that's an even bigger triangle, but they all have the same 6 trig values. So let's pick one that makes our numbers easy to work with. And who here likes fractions? No one? I don't either. Fuck fractions. So if we have y equals 3/2 x, and I don't want a fraction in it, what is a good x value?
1.
So I guess it sounded like I was finished. So that y isn't a fraction. We just said fuck fractions. If we try 1, what do I have for y? I have 3/2. Fuck all that. So I think I heard someone say 2. If I use x equals 2, y equals 3/2 times 2, which equals 3. But that's not quite right. That would be in this quadrant right here. I need x to be less than 0. So let's do x equals -2. So y equals 3/2 times -2. That'll give us -3. So we're gonna have that triangle right there. That's our ending triangle there. And I'll redraw it. So Davis and Keith, who's on Zoom right now, came to the Mesa Center on Saturday. And they were working on trig and got distracted by someone doing calculus. And so they tried to start doing calculus with them. I look at them like, what the hell are you guys doing? Stop! No! Don't! No! Stick to the class you're working on. Crackheads. Alright, so I've got -2, -3. What's r? We need r, because remember we need like sine theta is y over r, so I'm gonna need r. So r is gonna be the square root of x squared, which is -2 squared, plus y squared is -3 squared. That is the square root of 4 plus 9, which is the square root of 13. Unfortunately, doesn't make a nice clean number, so we're gonna have to leave it as square root. So sine of theta is -3 over the square root of 13. And if we rationalize the denominator, we don't like leaving radicals in the bottom, remember that from algebra? We get this is -3 root 13 over 13. When I do cosecant theta, I'm gonna use the one that's the easiest one to flip that gives me what I want in the end. If I flip this one, I got a radical in the bottom again. If I flip this one, the radical is no longer in the bottom, it's in the top. So let's flip that way. So I'll have negative root 13 over 3. And just because it's an ugly answer doesn't mean it's the wrong answer. You're going to find as you go through mathematics that the textbooks are often catered with nice problems that give you whole numbers and everything looks right as rain. But in reality, the real world very rarely has perfect numbers. Rarely. We don't build buildings so that the diagonal has like a perfect distance. It just doesn't happen. If we do cosine, x over r, so negative 2 over the square root of 13. And this follows the same pattern. We multiply by root 13 over root 13. And we get negative 2 root 13 over 13. And cosecant here, we'll flip that one. Negative square root of 13 over 2. And finally, tangent. Tangent theta is not bad. There's no fractions. Y over x is negative 3 over negative 2. So 3/2. Which means cotangent theta is 2/3. Take like a 7 or 8 minute break, give you guys a chance to stretch your legs, go to the bathroom or something like that. Pause the video real quick. All right, so let's continue on. So we have our 6 trig functions. There's ones that cause problems. And these are along the quadrantal angles. And I'm pretty sure we talked about that the other day. Quadrantal angles. These are your 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360. These are your axes. These are along either X or Y axis. So if we look at sine theta here, let's just pick a couple points here. Let's start with 1, 0. 1, 0 is right here, which means my ray is pointing directly to it, and theta equals 0 degrees, or we could do 360 degrees. So this is like saying sine of 0 degrees, cosine of 0 degrees. Oop, I put theta in. Tangent of 0 degrees. Well, we have x and y, what's r? R is remember, is the square root of x squared plus y squared. This is the square root of 1 squared plus 0 squared, which is 1. So x equals 1, y equals 0, r equals 1. Sine theta is y over r, which is 0 over 1, and we're not going to leave it as 0 over 1 because we know that equals 0. Cosine theta is x over r. One over 1 is 1. Tangent theta is y over x. We have 0 over 1, so another 0. No problem so far. The problem comes when we try to do the related reciprocal trig functions. If I do cosecant of 0 degrees, I have 1 over 0. Now I've got 0 in the denominator, shit breaks. We're going to say this is undefined. And if you want to abbreviate it undef, that is fine too. Secant of 0 degrees, that one flips over just fine. 1 over 1 is still 1. But cotangent has a problem as well. If I do 1 over 0, I have undefined again. What?
That would be 0 over 1.
No, tangent was 0 over 1. When we flip it,
So if 0 is under 1, it's going to be a undefined.
if 0 is under any number, it's undefined. You
Okay.
cannot have 0 on the bottom of a fraction. That's just basic mathematics. When you learn about division, it may not be the first thing you learn about division, but it's up there. It's one of the early ones. You cannot divide by 0. Division is the outcome of repeated subtraction. And it's like saying, like when we do 6 divided by 2, we're saying how many times can we subtract 2 from 6 before 6 is gone? So like 6 minus 2 is down to 4, 4 minus 2 is down to 2, 2 minus 2 is down to 0, we did it 3 times, 6 divided by 2 is 3. If we do 6 divided by 0, we're saying how many times can we subtract 0 before, if we're like 6 over 0, how many times can I subtract 0 before 6 is gone? It never goes away. 6 minus 0 is still 6. So division by 0 is I like to call this, you'll hear me say this. This is bad juju. I don't know where the hell I got that phrase, but I like it. Sounds like some voodoo shit. So let's say we have the point at like net or 0, -3. So my ray is going straight down here. X equals 0, y equals -3. If we calculate r, square root of 9 is 3. So r equals 3. Sine theta, cosine theta, tangent theta. Here, this is, that would be 90, 180. 270 degrees, so this is sine of 270 degrees. Well, sine was y over r, -3 over 3 is -1. And so if I flip over -1. I still get -1. This is x over r, 0 over 3 is 0. Which means when I do secant of 270 degrees. I have 3 over 0, so undefined. Finally, y over x, -3 over 0. Tangent is undefined. If I do cotangent of 270 degrees. Flip that, 0 over -3 is 0. Any questions? Yeah.
And this is, so this system can't actually use this to discern what it is. So if I didn't have 270, I couldn't use this to find out what 270 is.
If you knew sine was -1, you could. So some pieces of information you can work backwards. If you know sine is -1, or like, I'm gonna make a table right now. If you know any of the following are true. You can figure out what angle it corresponds to. We're actually gonna make a, rather than doing like a picture for each of the 4 quadrants. You're gonna see it follows a nice little pattern. So we get a column for theta. Column for sine. Column for cosine. And I'll do one for tangent. And we'll do our quadrantal angles right now. In the next section, we're gonna do the SOHCAHTOA. And we're gonna do like angles between. There's some ones in there that have nice, good fractional answers here for the angles. So at 0 degrees, sine is 0 and cosine is 1. And tangent is 0. If we do sine of 90 degrees, this is straight up. It turns out sine is 1 and cosine is 0. And we get tangent is undefined. This follows a nice pattern, you're gonna see. It's a very simple pattern. When we get to 180 degrees, we're back to flat line here. Y is 0, so sine is 0. Cosine is gonna end up being -1. Because the x is negative over there. And this is still 0. Then this becomes, we just did this one, this was -1, 0, and undefined. And 360 is back around to the start, it's the same thing as 0 degrees, so 0, 1, 0. Another bit that's handy, and I don't know why it's not in this section. We said sine theta equaled y over r. And I'm gonna divide that by cosine theta. So that's like x over r. There should be a y up there. So I got this complex fractions, fuck fractions, we don't like fractions, at least the better we can multiply this by r over r. And if I do like y over r times r, it's like r over 1, they cancel and I get y, so the top is y. And if I do x over r times r, it's like r over 1, the r's cancel. And I'm just left with x. So sine theta divided by cosine theta equals y over x. But what did y over x equal?
Tangent.
Equals tangent. So with this identity in mind, we don't even need that button column. Because you have sine and cosine and you can get tangent just by doing simple addition. Right? The less you have to memorize, the easier shit gets. I think. You may disagree, and if you disagree, there's more of a table. Any questions? Are we having fun yet? There is no right answer to this, you'll learn. If you're having fun, that means I need to keep doing it, and if you're not having fun, maybe the next problem will be more interesting.
I'm having fun.
That's the right answer. If you have to pick between the two, lie to the teacher and tell them you're having a great time. Or her. Or they, if they don't identify as a him or her. I go by he or him or his, those are my pronouns. If it matters to you, some people it very much matters to, and other people like, I don't give a shit. So. Cater to the crowd. Everyone ready for more? Alright, so let's do another table real quick. And we're gonna look at quadrants here. So I'll do quadrant sine, cosine, and tangent. That pin's dead. I can get rid of it. It's funny because they like to use Roman numerals for the quadrants. Remember, they go counterclockwise. So if, before we start filling this out, just think about what's going on here. What we're wanting to do is identify the signs for each. Positive or negative for each trig function by quadrant. So y could be positive or negative depending on where it is. Same with x. What about r? Is r ever negative? R is never negative, it's a distance, we don't have negative distances. So r is always positive. Positive, positive. So sine theta, sine and cosine all depends on y. Or sine all depends on y for sines. Cosine depends on x for or for sines. In this quadrant, both x and r are positive. Yeah, I saw it. Camera turned off. So who wants to tell me a story for 30 seconds? Cause it fucking does not ever want to turn back on, I gotta let it fucking completely power off. Tell me the story behind this big ass fucking suitcase of a pencil holder you're bringing.
So it's.
There it is, that makes sense. I'm like, what in the hell, that is a big box for pencils.
It came in a bigger one, like this.
No shit, what's in the bigger box?
That's on the smaller end.
It can't all be pencils, I mean, there's no way you need that many pencils for like a suitcase sized box.
Like,
Like rulers and triangles and shit. How much was it for the bigger box? How much?
115.
Not as much as I thought it could have been. Yeah,
Most of the stuff I found on Amazon. After I bought the big box, I was like looking.
can I buy each piece individually? Alright, I think this is good, yeah, there we go, let's turn back on. Wasn't that fun? So I'm gonna write this in terms of x, y here. In this quadrant, both of them are positive. In this quadrant, x is negative, but y is positive. In this quadrant, both of them are negative. And in this quadrant, x is positive and y is negative. Does that make sense? I don't know if you've ever stopped and thought about it, but like. That's how it always is, all the x values are negative to the left of this. And all the y values are negative below it. So if we're filling this in, like. Both sine and cosine should be positive. And even if you're not looking at y and x anymore, this is sine over cosine. Positive over a positive is positive. In quadrant 2, y is still positive, so sine is positive. X is negative, so cosine is negative. And a positive over a negative is negative. In quadrant 3, they're both negative. And if I do a negative over a negative, they cancel out, we're back to positive. And we finish it off in quadrant 4, y is negative, so sine is negative. X is positive, so cosine is positive. And so sine over cosine and negative over a positive is a negative. And if you want the signs for cotangent, secant, and cosecant, they're the same signs as tangent. Or all the same signs as the counterpart. Secant with cosine. Cosecant with sine. I hate that they letters switch like that. I don't know why they couldn't have just picked the words. Eight words that match. I'm sure they had the words before. Like secant is related to how a line intersects its shape. So I'm sure that's the problem. They didn't have sine and cosine yet. I don't know. You want to leave this up longer? You're almost done, right? And we can wait. Okay. We're gonna do some examples with these, just like say. Identify the signs. Of the 6 trig functions. So for A, we're gonna say theta equals 63 degrees. So which quadrant is this? This is in quadrant 1, right?
Yes.
Remember, quadrant 1 is between 0 and 90. So this is quadrant 1. Quadrant 1. We had sine was positive, cosine was positive, tangent was positive. Which means their counterparts all have the same signs as well. Everything is positive in the first quadrant. What about 193 degrees? Which quadrant is that in?
In the third quadrant.
That is the third quadrant. So Q2 would be 90 to 80. Or 180, sorry. So that's not it. Q3 is 180 to 270. So this makes this Q3. So in quadrant 3, we're down here. And down here, they're both negative. X and Y are both negative. So sine is negative. Cosine is negative. Tangent is sine divided by cosine, it's positive. And when we flip them, same signs. Alright. What about? Negative 72 degrees.
And the fourth quadrant,
Let's see, if we go like positive would be that way, so we wanna go that way for a negative angle. And so we're 90, a negative 90 would get us down to here, so negative 72 is like to there. So that does look like the fourth quadrant. Quadrant 4 being 270 to 360. That's a reminder. Over on that quadrant, x is positive and y is negative. So sine theta, cosine theta, tangent theta. Just writing them all out real quick. Sine's got a y value, same sign as y is negative there, so this is a negative in quadrant 4. Cosine is positive there. And tangent is sine over cosine, negative over positive is negative. Which means these all have the same values as their reciprocal. Ready for some more fun?
of course,
Alright, so we said the reciprocal functions earlier. I said sine theta. Was 1 over cosecant theta. No, I said the other way around. I told you cosecant theta was 1 over sine theta. But both of these are true. And we said secant theta was 1 over cosine theta. But I can flip those upside down. And I can say cosine theta equals 1 over secant theta. And tangent theta was, oh, I said cotangent was 1 over tangent. But that can flip, and tangent theta can be 1 over cotangent theta. That's the full reciprocal identities. These are all of the reciprocal identities. The 3 on the left don't show up that often because you usually have sine, cosine, and tangent before you have the other 3. It's worth noting, it's important, this is actually really important, for any angle theta. Both sine theta and cosine theta have values between -1 and +1. Including those values. They cannot be larger or less than those numbers. So basically, they're either 1, -1, or they're a decimal. Both tangent theta and cotangent theta can be anything. And if we look at cosecant and secant, these have like, there's some issues here. So like cosecant theta. Is either less than to equal to -1, or cosecant theta is greater than or equal to +1. And the same thing happens with secant theta. This is not an ideal way of doing this. So I'm gonna write it in that interval notation. -∞ to -1. In union with 1 to infinity. For either of these. So if you like looking at number lines, like a number line approach is actually pretty handy here. Sine and cosine can be in here. And if I go to the left or to the right of there. This is our cosecant or secant. And then cotangent, tangents anywhere. So you might see some questions like this. Are these possible or impossible? Can cotangent theta equal -0.9999999? Yeah, tangent and cotangent could be anything. And sine of theta equal 2.7. No. Sine theta was between -1 and 1. And cosecant theta equals 0. Yeah. If it helps you stop and think about. Cosecant or sine is. Y over R, so cosecant. Theta is R over Y. And that would have this, can that equal 0? Can R equal 0? No. Like that, if it is, we don't have an arrow. So no. But if you look by the rules, same thing applies. So let's do something that's fun. I think it's fun. Hopefully you think it's fun. Let's say. That. Theta. Points to quadrant 3. And then. Tangent theta. Equals. Let's go with. I don't know, 4/9. Find the 6 trig values. Now, them giving us tangent theta equals 4/9 is not enough. Tangent is positive up here and tangent is positive down here. So that's why they gotta give us more information. Here, they tell us we're in quadrant 3. Down here is quadrant 3, so we're down there. So if I magnify this out a little bit. I have tangent theta equals 4/9. Well, what does tangent theta equal? In terms of.
Sine over cos. Sine
It's
over
sine over
cosine.
cosine, but
X and Y.
it's x and y, right? Or y over x is the better way to look at it. So that means like if I make this triangle here, this vertical distance is 4. This horizontal distance here is 9. But we're in quadrant 3, which means that's -4. And this is -9. So those are our actual x and y values. That makes sense to everybody?
Yeah, it's clear.
Alright, so. To do the rest, we have x, we have y, we need r. R is the square root of x squared plus y squared, that hasn't changed. -9 squared plus -4 squared. +81 plus 16. is square root of 97. Which I'm pretty sure is not a nice number. So I'll just leave it as that. But now we have R. So now we can find our 6 trig functions. Why don't you guys do that real quick, and then I'll do it together with you in like a minute. You should end up with -4 times the square root of 97 over 97 for sine. After you deal with the rationalizing the denominator. And this one should be negative square root of 97 over 4. -9 root 97 over 97. I know, it's not the most exciting part of math, having to get rid of that square root on bottom. And that one was easy, we already had 4/9, so this one is just 9/4. Folks are still right, be patient if you're done. Does anyone need this page up longer? Okay. So. A couple important things to note. Recall. That if we have like x to the -1. That means 1 over x. That's from algebra, right? The negative exponents mean flip it. This is not the same with trig. Sine -1 of x like that does not equal 1 over sine x.
That's the inverse
It's the
function of the
inverse.
trigonometric.
And we're not doing it yet, but I wanna point this out in case it pops up. It's. Inverse of sine x. So, but again, -1 up above doesn't mean the same thing. And for the next part, I wanna point out something for you. If we have sine theta equals y over r. It means that y equals r sine theta. I'm just clearing the fractions. Does that make sense? Just cleared the fractions. And cosine theta equaling x over r. Means if I multiply both sides by r, I get x equals r cosine theta. This is kind of important because this leads to the next thing here. We started with. X squared plus y squared equals r squared. Equation of a circle. Let's take these and plug these in. So the square on this means both of these get squared. And unfortunately, this is why I had to point out that sine to the -1 there. Doesn't equal a -1 power. This is how we write cosine squared. This is the same thing as cosine theta squared. They got tired of writing parentheses, so they just wrote it with the exponent in front of cosine. And they just want to make sure that like. Any number here besides -1 means it's an exponent. If it's a -1 though, it means inverse. But. Here I can factor out an r squared of both terms. And r can't equal 0, right? So we can divide by it. R does not equal 0, so we can divide both sides by r squared. And if we do that, we get cosine squared theta plus sine squared theta equals 1. Now there's two, this is called the Pythagorean identity. But I'm gonna say identities because there's two more. And I'll show you how you get it. This is the most important one to memorize. It shows up in calculus left and fucking right. All the time. It's all like so much. But if I start with cosine squared theta and sine squared theta equals 1. If I divide this by cosine squared theta on both sides. I'm gonna get my next identity. Cosine divided by cosine is just 1, they cancel each other out, this is 1. This is saying sine theta squared over cosine theta squared. Well, that's just the same thing as sine over cosine squared. So that part's tangent squared. And 1/, cosine is secant. So 1/, cosine squared, this is the same as 1/, cosine squared. That ends up being secant squared. Now, you can memorize this. Or you can just know how to find it. Up to you.
Yeah. Yes.
And we have a third one. Again, we'll start with cosine squared and sine squared theta equals 1. This time we'll divide by sine squared. The same idea happens. We get cotangent squared theta plus 1 equals cosecant squared theta. These are the 3 Pythagorean identities for trigonometry. And this is under the assumption the trig functions are defined. Like we had a couple of those functions like of 90 degrees and 0 degrees, some of them are not defined, so you can't do it. Again, the top one is the one that's the most important. Because the other 2 can be derived from it, you can come with up with them just by division. And once you're more comfortable with these trig functions, it's actually not that hard. If you're not comfortable with the trig functions yet, you're like, that's a lot. I actually have them listed in their order of importance. In calculus, the one on top shows up the most. The second one that shows up is the secant squared one. For some reason, secant and tangent get a lot more love than the cosecant and cotangent. Don't know why. Just happens to be the case. Almost done. This was a busy day, it's a long section. So we can actually use these to find part of the answer to the problems also. Let's say sine theta. If sine theta equals negative square root of 2/3. And cosine theta is greater than 0. Find cotangent, not cotangent, find cosine theta and tangent theta. One approach, and we're not doing it this way. Because we already did it. We can say, okay, well, sine is negative down here. And sine is negative down here. But cosine's positive over here. And cosine's negative over here. So we must be in this quadrant. Which means the y is like the square root of negative or square root of 2, and r is 3. And we could go that way. We could figure out what x is and stuff like that. Let's take advantage of our identities though. We could also say cosine squared theta plus sine squared theta equals 1. So cosine squared theta plus negative square root of 2 over 3 squared equals 1. Cosine squared theta, I square that, the top is 2 and the bottom is 9. I'm gonna rewrite that as 9 over 9. So that I can subtract 2 9s from both sides. Take the square root of both sides. So cosine theta equals, normally it would be positive or negative, square root of 7 over 3. But this is where we make sure we say, okay, cosine was positive. So just the positive one. Finally, we'll finish it off with tangent is sine over cosine. Give square root of 2 over square root of 7. Get negative square root of 14 over 7. And that'll be it for today. And all GTFO when you're done writing, or read quietly, have a good day. If you have any questions, anyone have any questions? We had a busy day, there was a lot of that happening.
I have questions later on.
Okay. I do get here by 7:30, keep that in mind. So if you like have questions and don't email me before then, you can always come in early and ask questions. And I will be here for you guys. Other than that, have a good day. May your second week of school go great.
All right, take care, Professor Jones.
You too, Keith.